I had number 7 on problem set 10, and we had changed the numbers so that the first circle has center of 0, 0, and the radius is equal to 3, and the second circle has center 1, radical 5, and the radius is equal to 2. And the question was, find the radius of the smallest circle that contains both. So the first thing that I did was I drew a picture. So the one centered at 0, 0 has a radius of 3. That's the point 0, 0. And then the second circle has a center of 1, radical 15. Oops. Should be right over here. Just below 4. And it has a radius of size 2. And this has a radius of size 3. So then what I did is I broke it up into 3 sections. So I went from the origin, which is the center of this circle, to the center of this circle, which is 1, radical 15. And I drew a triangle straight up. And then down to the point 1, 0, and over. So if I pull this triangle out, it has a y value of radical 15 and an x value of 1. And this is because the center has an x value of 1 and a y value of radical 15. And then using Pythag, I figured out this distance. So I knew that x squared is equal to 1 squared plus radical 15 squared. And x squared is equal to 1 plus 15. And x is equal to 4. So I know that this distance right here is equal to 4. So for a circle to contain both, it needs to go all the way around and out. So I know that its diameter has to go through the centers of both of them and then continue out. So I know that this distance was 4, and from this center out to this point, the furthest point on this circle, is equal to 2 because that is the radius. And then I can do the same thing from this center out to its widest point is equal to 3. So I know that the diameter of the circle that I'm looking for that contains both is equal to the distance that I found between the centers, which is 4, plus the radius of the largest circle plus the radius of the smaller circle. So that is equal to 9. So therefore, I know that the radius is equal to 9 over 2, which is the diameter over 2, which gets me 4.5. So this is the answer because the circle that contains both is from the widest point of each circle and runs through the centers of both. So I could find the distance between the centers plus the radius of both of the circles to find the diameter, which then gives me the radius.